Close your eyes and listen. Your heart beats once. Then again. Each beat marks a moment passing through the river of time. This river flows all around you. It carries your thoughts downstream. It lifts your dreams and sets them gently on tomorrow's shore. Right now, in this quiet moment, time moves through you like water through smooth stones. You have lived in this river your entire life. Every birthday candle you have blown out. Every Christmas morning you have awakened to. Every sunset you have watched paint the sky in gold and purple. All of these moments float along time's current, one after another, in perfect order. But tonight, we begin a journey together. A journey to discover something wonderful and strange. Something that will change how you think about this river forever. The river of time feels steady and unchanging. It seems to flow at the same speed everywhere. Past your bedroom window. Through your neighborhood. Across the oceans. Beyond the clouds. Out to the stars themselves. Your heartbeat keeps perfect time with this cosmic rhythm. 60 beats each minute. 1440 minutes each day. Your body is a living clock, marking time's passage with each breath you take. Scientists call this feeling the flow of time. It moves forward, never backward. It carries you from birth toward your future. It ages the trees in your yard. It turns puppies into old dogs. It moves the moon through its phases and brings the seasons in their turn. For thousands of years, people believed this river flowed the same way for everyone. They thought time moved at exactly the same speed whether you were sitting still or running fast. Whether you lived on a mountain top or deep in a valley. Whether you traveled to distant lands or stayed home by the fire. They were wrong. About 100 years ago, a young man with wild hair and curious eyes began to wonder about time. His name was Albert Einstein. He asked questions that no one had asked before. What if time could speed up? What if it could slow down? What if this river we live in could bend and curve like a real river? Most people laughed at his questions. Time is time, they said. It flows the same for everyone. But Einstein kept wondering. He kept asking. He kept imagining what might be possible. And then he discovered something amazing. Time is not like a straight, unchanging river after all. It is more like a gentle stream that can speed up and slow down. It can curve around massive objects. It can stretch and compress like warm taffy on a summer day. This discovery changed everything we thought we knew about the universe. Tonight, as you rest here in your bed, time flows around you at its normal, comfortable pace. The seconds tick by steadily. Your clock marks each minute as it passes. Everything feels familiar and safe. But imagine this. Imagine you could somehow move very, very fast. Faster than the fastest car. Faster than the fastest airplane. Faster than anything you have ever seen. If you could move fast enough, something magical would happen. Time would begin to slow down around you. The seconds would stretch longer. Minutes would feel like hours. Your heartbeat would seem to slow to a gentle whisper. This is not science fiction. This is real science. This is one of the most beautiful discoveries humans have ever made about our universe. The faster you move through space, the slower you move through time. This invisible dance happens all around us every single day. Most of the time, we move too slowly to notice it. But it is always there, like a secret song playing just beyond our hearing. Right now, as you lie still in your bed, you are actually moving. You are spinning with the Earth as it turns on its axis. You are traveling with the Earth as it circles the Sun. You are flying through space with the Sun as it moves through our galaxy. You are already a time traveler. You just never knew it. Every step you take moves you slightly into the future. Every car ride. Every airplane flight. Each one carries you forward through time in a way that is different from someone who stays perfectly still. The difference is tiny. So small you could never feel it. But it is real. It is measurable. It is one of the most wonderful secrets the universe has ever shared with us. Scientists have proven this with the most precise clocks ever built. Clocks so accurate they can measure time down to billionths of a second. When these clocks travel fast, they slow down compared to clocks that stay at rest. Time truly can stretch and bend. This means that somewhere out there, in the vast universe beyond your window, time is flowing at different speeds. On distant planets. Around massive stars. In the depths of space where gravity grows weak and objects move incredibly fast. Time is not the steady river we once believed it to be. It is something far more mysterious. Far more beautiful. Far more alive with possibility. Your heartbeat continues its steady rhythm as these thoughts settle in your mind. Each beat marks another moment in your personal journey through time. But now you know that this journey is more complex and wonderful than you ever imagined. As you drift towards sleep, think about this. The universe is filled with clocks running at different speeds. Some tick faster than yours. Some tick slower. All of them marking time's passage in their own unique way. And you are part of this cosmic symphony of time. Tomorrow morning, when you wake up, you will have traveled through the night to a new day. You will have moved forward through time while you slept. This journey happens so naturally that you never think about it. But tonight, as your eyes grow heavy and your breathing deepens, you can marvel at this invisible river that carries you forward. You can wonder about its currents and its mysteries. And you can begin to imagine what it might feel like to discover that this river holds even more secrets than we ever dreamed. Picture a young man sitting by his window on a quiet afternoon. His name is Albert Einstein. He is 16 years old. His dark hair falls across his forehead as he gazes out at the sunlight streaming through the glass. A simple question enters his mind. A question that will change the world. What would it look like to ride alongside a beam of light? Most people would dismiss such a thought as silly daydreaming. But Einstein's mind works differently. He lets his imagination carry him forward. He closes his eyes and begins to travel. In his mind, he speeds up. Faster and faster. He matches the pace of the sunlight flowing past his window. He becomes a companion to the photons dancing through space. Together, they race across the countryside. Over mountains. Through clouds. Beyond the atmosphere itself. What does he see on this impossible journey? Einstein expects the light around him to slow down and stop. After all, if you run alongside a river, the water seems to move more slowly past you. If you ride next to a train, it appears to stand still. But something strange happens in his imagination. The light refuses to slow down. No matter how fast he travels, the light beam beside him continues to move at its same incredible speed. It flows past him as if he were standing perfectly still. This troubles the young Einstein. It makes no sense according to everything he has learned about motion. If he can catch up to a running horse, why can't he catch up to a ray of light? He carries this question with him for years. Through his studies. Into his work as a clerk in a patent office. During long walks with friends. While playing his violin in the evenings. The question grows inside him like a seed in fertile soil. Einstein begins to realize that light must be special. Different from everything else in the universe. Horses can be caught. Trains can be matched. Rivers can be overtaken. But light seems to follow its own mysterious rules. He discovers that light always travels at the same speed. Always. Whether you are moving toward it or away from it. Whether you are standing still or racing through space. Light maintains its constant pace like a cosmic heartbeat that never changes. This discovery leads Einstein to an even more startling thought. If light's speed never changes, then something else must change instead. Something we never expected. Something so fundamental that it touches every moment of our lives. Time itself must be flexible. Einstein realizes that when you move very fast, time slows down around you. Not because your clocks break. Not because your mind plays tricks. But because time itself stretches like warm honey in the sun. Imagine you are on a train racing through the countryside. To you, inside the train car, everything feels normal. Your watch ticks at its usual pace. Your heartbeat keeps its steady rhythm. Time flows just as it always has. But to someone standing on the platform as you rush past, something magical is happening. Your watch appears to tick more slowly than theirs. Your movements seem dreamlike and gentle. Time around you has stretched into something longer and more graceful. This is not an illusion. This is reality. Time truly moves more slowly for objects in motion. The faster you travel, the more dramatic this effect becomes. At everyday speeds, the difference is too small to notice. When you walk to school or ride in a car, time barely changes at all. But as you approach the speed of light, time stretches more and more. Einstein works out the mathematics of this strange new world. He discovers that nothing with mass can ever reach light speed. As objects move faster and faster, they become harder and harder to push. It would take infinite energy to accelerate anything to light's pace. Light itself has no mass. This is why it can travel at its special speed. This is why it becomes the universe's ultimate speed limit. The cosmic boundary that shapes how time and space work together. Einstein calls this discovery special relativity. It describes how motion affects the flow of time. How space and time dance together in ways no one had imagined before. But Einstein's mind doesn't stop there. His curiosity carries him deeper into the mystery. He begins to wonder about gravity. About massive objects like stars and planets. About how they might bend and curve the fabric of space itself. These thoughts lead him to an even grander discovery about time. But those revelations wait for another part of our journey. For now, rest in the wonder of Einstein's first great insight. The universe is far stranger and more beautiful than anyone had dreamed. Time is not the rigid ruler we once believed it to be. It is alive. Flexible. Responsive to motion in ways that feel like magic but follow the deepest laws of nature. As you lie in your bed tonight, you are surrounded by this invisible dance. Light streams past your window at its eternal, unchanging speed. Time flows around you at its gentle, earthbound pace. But now you know that this pace could change. That motion holds the key to time's hidden flexibility. Einstein's 16-year-old question opened a doorway into the deepest secrets of reality. His imagination, racing alongside that beam of light, revealed truths that still take our breath away more than a century later. Scientists have tested Einstein's ideas thousands of times. With the most precise instruments ever built. In laboratories. In space. Around the world. Every test confirms what that curious young man discovered through the power of pure thought. Time truly does slow down for objects in motion. Your dreams tonight might carry you on journeys through space and time. You might find yourself racing alongside Einstein's beam of light. You might experience the gentle stretching of time that comes with incredible speed. These dreams would not be fantasies. They would be glimpses into the actual structure of our universe. Into the way reality truly works beneath its calm, familiar surface. Einstein's gift to us was not just a new understanding of time. It was permission to wonder. To question. To imagine impossible journeys that turn out to be windows into truth. As your breathing deepens and your thoughts begin to drift, remember that young man by his window. Remember his willingness to follow a simple question wherever it might lead. Close your eyes and imagine a single ray of sunlight. It begins its journey 93 million miles away, born in the heart of our star. In just 8 minutes and 20 seconds, it travels across the vast emptiness of space to touch your face through your bedroom window. This journey happens at a very special speed. A speed so important that the entire universe seems built around it. Light travels at 186,282 miles per second. every second. Without fail. Without change. This speed never varies, no matter what happens around it. Think about how remarkable this is. When you run, you can speed up or slow down. When a car drives down your street, it can accelerate or brake. When birds fly overhead, they can soar faster or glide more slowly. But light is different. Light always moves at exactly the same speed. If you could somehow run toward a flashlight beam, the light wouldn't reach you any faster. If you could race away from that same beam, it wouldn't take any longer to catch up with you. The light beam would always pass you at precisely 186,282 miles per second. This seems impossible. It goes against everything we know about motion in our everyday world. Yet it is one of the most tested and proven facts in all of science. Scientists call this the speed of light in a vacuum. In the emptiness of space, where there is no air to slow it down, light maintains this perfect, unchanging pace. It becomes the universe's most reliable constant. But why does light behave this way? What makes it so special? The answer lies in what light truly is. Light is not made of tiny particles like marbles rolling down a hill. It is not made of waves like ripples on a pond. Light is something more mysterious and beautiful than either of these simple pictures. Light is a wave in the invisible fabric of space itself. It is electricity and magnetism dancing together in perfect harmony. Scientists call this dance an electromagnetic wave. When you turn on a lamp, you create these waves. They ripple outward from the bulb like circles expanding on a still lake. But instead of moving through water, they move through the hidden structure of space and time. This is why light speed is so special. It is not just the speed at which light travels. It is the speed at which space and time themselves can carry information from one place to another. Imagine space and time as a vast ocean. This ocean has a natural speed limit. No wave can move through it faster than 186,282 miles per second. Light waves happen to move at exactly this limit. This is why light always travels at the same speed. It is surfing on the fastest possible wave that space and time can support. Other things can travel at this speed too, but only if they have no mass. Only if they are pure energy, like light itself. Anything with mass, anything you can touch or hold, must travel slower than this cosmic speed limit. This speed limit shapes everything in our universe. It determines how fast information can travel from place to place. It sets the boundary between what is possible and what is not. And most importantly for our journey tonight, it is the key that unlocks time's flexibility. Here is the beautiful secret Einstein discovered. The universe insists that light speed must always be the same for everyone, everywhere. But to make this possible, the universe allows something else to change instead. It allows time itself to bend and stretch. When you move very fast, time slows down around you to make sure that light still passes you at its constant speed. When you slow down, time speeds up to maintain light's steady pace. The universe adjusts the flow of time itself to preserve light's sacred rhythm. Think of it like this. Imagine you are floating on a river, and someone throws you a ball at the same speed every time. If the river current speeds up and carries you downstream faster, the ball seems to approach you more slowly. If the current slows down, the ball seems to reach you more quickly. But what if the ball had to reach you at exactly the same speed every time, no matter how fast the river carried you? The only way this could happen is if time itself sped up or slowed down to make the ball's approach feel the same. This is exactly what happens with light in our universe. Time adjusts itself to keep light's speed constant. As you rest in your bed, light from your lamp travels to your eyes at this same eternal speed. Light from the stars outside your window crosses billions of miles of space, never changing its pace. Light from distant galaxies, born when the universe was young, still moves at precisely 186,282 miles per second as it reaches Earth tonight. This constancy creates a kind of cosmic heartbeat. A rhythm that connects every corner of the universe. From the smallest atom to the largest galaxy, everything is synchronized to this fundamental speed. But light's constant speed creates consequences we never expected. It means that astronauts orbiting Earth experience time slightly differently than people on the ground. It means that particles racing through laboratories live longer than they should. It means that the universe is far stranger and more flexible than anyone imagined before Einstein. Every time you turn on a light switch, you're witnessing one of nature's greatest mysteries. You are seeing energy transform into electromagnetic waves that travel at the universe's ultimate speed limit. You are watching space and time carry information across the room at their maximum possible rate. The light reaching your eyes right now left its source just moments ago. But in those moments, it traveled at a speed so precise, so perfect, that it required the entire fabric of reality to adjust around it. This is why light holds the key to understanding time. This is why Einstein's journey began with a simple question about racing alongside a light beam. Light's unwavering speed forces time to be flexible. It reveals that time is not the rigid ruler we once thought it was, but rather a gentle stream that can speed up, slow down, and bend around the universe's deepest laws. As your breathing deepens and your thoughts begin to drift, picture that ray of sunlight that began this chapter. See it traveling through space at its eternal, unchanging speed. Feel how the universe bends time around this cosmic constant to keep everything in perfect harmony. Tomorrow morning, when sunlight streams through your window to wake you, you will witness this miracle again. You will see light maintaining its sacred speed while time dances around it in ways both invisible and profound. Imagine you have two identical clocks sitting on your nightstand. They are perfect twins. Built by the same hands. Wound by the same key. Their pendulums swing in perfect harmony, marking each second with the same gentle rhythm. Now imagine something magical. One of these clocks begins to float. It rises from your nightstand and drifts toward your window. It passes through the glass like a ghost and continues upward into the night sky. Higher and higher it climbs. Past the clouds. Beyond the atmosphere. Into the vast darkness of space itself. But this clock doesn't just float. It begins to move. Slowly at first, then faster and faster. It races past the moon. It speeds toward Mars. It accelerates until it reaches a significant fraction of light's sacred speed. What happens to this traveling clock compared to its twin that remains peacefully on your nightstand? Einstein's equations give us a startling answer. The racing clock begins to tick more slowly. Its seconds stretch longer. Its minutes expand like taffy pulled gently between warm fingers. To you, watching from your bedroom, the traveling clock appears to run slow. Its hands move with dreamlike grace. Each tick becomes a whisper. Each talk becomes a sigh. This is not because the clock is broken. This is not because space has damaged its delicate gears. This happens because time itself moves more slowly for objects in motion. The faster the clock travels, the more dramatic this effect becomes. At half the speed of light, the clock runs noticeably slower. At 90% of light speed, it crawls like honey on a winter morning. As it approaches light's ultimate speed, the clock's ticking nearly stops altogether. Scientists call this time dilation. Time stretches and expands for objects moving at high speeds. But here is the most beautiful part of this mystery. To the traveling clock, nothing seems different at all. If you could somehow ride alongside that racing timepiece, you would see it ticking normally. Its rhythm would feel familiar and steady. Its hands would move at their usual pace. From your perspective on the speeding clock, time flows just as it always has. It is only when you compare the two clocks that the magic becomes visible. When the traveling clock finally returns to your nightstand, you discover something wonderful and strange. Less time has passed for the clock that journeyed through space. The traveling clock shows an earlier time than its earthbound twin. It has experienced fewer seconds, fewer minutes, fewer hours during its cosmic voyage. Time dilation has allowed it to slip gently into the future. This might sound like science fiction, but it happens constantly in our universe. Every day. Every hour. Every second. Scientists have tested this with the most precise clocks ever built. Atomic clocks that measure time by counting the vibrations of individual atoms. These clocks are so accurate they would not gain or lose even 1 second in millions of years. When scientists put one of these atomic clocks on a fast airplane and fly it around the world, something remarkable happens. When the airplane lands, the traveling clock shows a different time than an identical clock that stayed on the ground. The difference is tiny. Just a few billionths of a second. But it is real. It is measurable. It proves that Einstein was right about time's flexibility. Even more amazingly, this happens with particles too small to see. In laboratories around the world, scientists accelerate tiny particles to incredible speeds. Particles called muons, which normally live for just a few millionths of a second. But when these muons race through particle accelerators at nearly the speed of light, they live longer than they should. Time dilation stretches their brief lives, allowing them to travel much farther than would otherwise be possible. This is how nature reveals her secrets. Through experiments so precise, so carefully designed, that they can measure time's gentle bending even when the effect is smaller than a heartbeat. Your heartbeat, resting here in your quiet bedroom, marks time at its earthbound pace. Each beat measures a second that feels familiar and steady. But now you know that this pace is not universal. Not unchanging. Not the same everywhere in the cosmos. Right now, particles from distant stars are racing toward Earth at tremendous speeds. For these cosmic travelers, time moves more slowly than it does for you. Their journey across the galaxy takes less time from their perspective than it would from yours. High above your head, satellites orbit Earth at thousands of miles per hour. These satellites carry atomic clocks that tick slightly slower than identical clocks on the ground. Engineers must account for this time difference every day, or our GPS systems would quickly become useless. Even the International Space Station, circling Earth every 90 minutes, experiences time a tiny bit differently than we do down here. The astronauts aboard age just a fraction slower than their friends and family on the ground. You are surrounded by time dilation. It flows through your daily life like an invisible river. Most of the time, the effects are too small to notice. But they are always there, gently bending time according to the laws Einstein discovered. As you settle deeper into your bed, think about those two clocks from our thought experiment. One resting peacefully beside you. One racing through the cosmos at unimaginable speed. Both keeping perfect time in their own reference frames. Both experiencing the flow of moments in their own unique way. This is the universe we live in. A place where time can stretch and compress. Where motion and stillness experience duration differently. Where the faster you move through space, the slower you move through time. Your dreams tonight might carry you on journeys like that traveling clock. You might find yourself racing through space while time stretches gently around you. These dreams would not be fantasies. They would be glimpses into the actual nature of our remarkable universe. Picture two sisters born on the same spring morning. They arrive into the world just minutes apart, sharing their first breaths of the same gentle air. They grow up side by side, running through the same meadows, chasing the same butterflies, dreaming under the same starlit sky. Their names are Elena and Maria. They have the same bright eyes, the same curious minds, the same love of adventure. On their 20th birthday, they make identical wishes as they blow out their candles together. But life carries them toward different paths. Elena becomes an astronaut. She dreams of distant worlds and alien sunsets. She trains for years, learning to navigate the vast ocean of space. Her heart yearns for the stars that twinkle beyond Earth's protective atmosphere. Maria becomes a gardener. She finds her joy in nurturing seeds into flowers, in watching trees grow tall and strong. Her hands know the gentle touch that helps life flourish. Her heart finds peace in the quiet rhythms of the changing seasons. When the sisters turn 25, Elena receives an extraordinary invitation. Scientists have built a spacecraft capable of traveling at incredible speeds. They need someone brave enough to journey to a nearby star and return with observations that could change our understanding of the universe. The journey will take 20 years of Earth time. 10 years to reach the distant star. 10 years to return home. Elena accepts the mission with excitement dancing in her eyes. Maria hugs her sister goodbye with tears mixing joy and sorrow on her cheeks. They promise to reunite when Elena returns, to share stories of their different adventures. Elena's spacecraft accelerates gradually, building speed over many months. Eventually, it reaches 80% of light's sacred speed. At this tremendous velocity, she races toward her celestial destination while time begins its mysterious dance around her. From Elena's perspective aboard the spacecraft, her journey feels perfectly normal. Her clocks tick at their usual pace. Her meals come at regular intervals. She ages day by day, month by month, year by year. The 10-year journey to the distant star passes as 10 years should. But something magical is happening that Elena cannot directly perceive. Back on Earth, Maria tends her garden through 20 springs and 20 winters. She watches her flowers bloom and fade through 20 complete cycles. She celebrates 20 birthdays, each one marking another year of her life's gentle passage. Meanwhile, Elena experiences only 12 years during her entire journey. Time dilation has stretched her years like warm clay in an artist's gentle hands. The faster her spacecraft travels, the slower time moves around her. When Elena finally returns to Earth, she steps out of her spacecraft as a 37-year-old woman. Her hair still shines with youth. Her step still carries the lightness of someone in the prime of life. Maria, now 45 years old, waits at the landing pad to welcome her sister home. 8 additional years have painted gentle lines around her eyes. Her hair carries threads of silver like moonlight on dark water. The sisters embrace with tears of joy, but something profound has changed between them. They are no longer the same age. Time has carried them along different paths, aging them at different rates. This beautiful, puzzling scenario is called the twin paradox. It shows us how motion through space affects the passage of time in ways that feel impossible yet follow the deepest laws of nature. But why does time affect Elena and Maria differently? Why doesn't the effect work both ways? The answer lies in the nature of their journeys. Maria follows a smooth, uninterrupted path through space-time. She moves with Earth as it orbits the Sun, never accelerating to extreme speeds, never changing direction dramatically. Elena's journey is different. She must accelerate to reach her incredible speed. She must decelerate when she arrives at the distant star. She must accelerate again to begin her return journey. Finally, she must decelerate once more to land safely on Earth. These periods of acceleration break the symmetry between the sisters' experiences. They create the conditions that allow time dilation to paint them differently. During Elena's acceleration phases, she feels pressed back into her seat by forces stronger than gravity. During these moments, she experiences time's flow in ways that differ from Maria's steady earthbound existence. It is not the constant high speed that creates the age difference. It is the changing speed. The acceleration and deceleration that Elena must endure to complete her cosmic journey. This paradox has been tested with atomic clocks flown around the world in airplanes. When the clocks return, they show less elapsed time than identical clocks that remained stationary. The traveling clocks have experienced time dilation just as Elena does on her star journey. Scientists have also observed this effect with particles in accelerators. Unstable particles that should decay quickly live longer when accelerated to high speeds. Their internal clocks run slower, giving them extended lifespans that allow them to travel farther than should be possible. The twin paradox teaches us something profound about the nature of time. It shows us that time is not the universal constant we once believed it to be. Instead, time is flexible, personal, and dependent on how we move through the fabric of space-time. As you rest in your bed tonight, think about Elena and Maria's story. Consider how their different paths through life led them to experience time's passage differently. Their love for each other remained constant, but time itself became a variable in their shared story. This paradox might seem sad at first. The sisters can never again share the same age. They can never return to the perfect symmetry of their childhood. But there is beauty in their difference. Elena brings back knowledge from distant stars that enriches all of humanity. Maria's garden grows more beautiful with each passing season, nurtured by hands that have learned patience through decades of practice. Their story shows us that time is not just a number on a clock. Time is a canvas on which our lives are painted. Some journeys paint us with broad strokes of adventure. Others paint us with delicate details of quiet dedication. Both paths have their own beauty. Both contribute to the rich tapestry of human experience. The universe allows for these different experiences of time because it is more flexible and more generous than we ever imagined. It gives us room to grow, to explore, and to age at the pace that matches our chosen journey. Elena and Maria's paradox reminds us that every moment is precious precisely because time is not the same for everyone. Each second we experience is unique to our own path through the cosmos. As your breathing deepens and your thoughts begin to drift toward sleep, imagine the sisters meeting again after their long separation. Picture their embrace. Feel the love that transcends the different ways time has touched their lives. Right now, as you lie in your bed, something invisible is pulling gently at every atom in your body. This force draws you toward the center of the earth with patient, steady persistence. You feel it as weight. As the soft pressure of your back against the mattress. As the way your arms rest naturally at your sides. This force is gravity. And gravity holds a secret about time that is even more beautiful than the mysteries we have already discovered together. Your feet, pressed closer to Earth's center, experience time slightly differently than your head, lifted higher on your pillow. The difference is impossibly small. So tiny that all the clocks in the world could not measure it over the span of a human lifetime. But it is real. It is always there. Gravity gently stretches time wherever its influence is felt. Einstein discovered this connection between gravity and time through another journey of pure imagination. He pictured himself inside an elevator with no windows, floating in the darkness of space. If someone pulled the elevator upward with constant acceleration, Einstein would feel pressed against the floor. His feet would feel heavy. Objects would fall when he dropped them. Everything would feel exactly like gravity's familiar embrace. This led him to a startling realization. Gravity and acceleration are twins. They affect the universe in identical ways. And if acceleration can slow down time, then gravity must slow down time as well. The stronger gravity becomes, the more dramatically it stretches each passing moment. Near massive objects like stars and planets, time flows more slowly than it does in the emptiness of space. The deeper you go into gravity's embrace, the more gently time cradles you. Picture our sun, that golden giant that warms your days and lights your world. Its enormous mass creates a depression in the fabric of spacetime, like a bowling ball resting on a stretched rubber sheet. Near the sun's surface, time moves more slowly than it does here on Earth. If you could somehow survive the sun's intense heat and place a clock on its surface, that clock would tick more slowly than an identical clock in your bedroom. Minutes would stretch longer. Hours would expand like flowers opening to morning light. This is not because the sun's heat affects the clock's machinery. This happens because gravity itself bends time around massive objects. The effect grows stronger as gravity grows stronger. Imagine objects far more massive than our sun. Neutron stars so dense that a teaspoon of their material would weigh as much as a mountain. Around these cosmic giants, time stretches dramatically. And then there are black holes. These are places where gravity has become so strong that not even light can escape. Near a black hole's edge, time slows to an almost dreamlike pace compared to the flow of time in safer regions of space. If you could watch someone falling toward a black hole from a safe distance, you would see them moving more and more slowly as they approached the edge. Their movements would become graceful and languid, like a dancer moving through thick honey. To them, falling toward the black hole, time would feel perfectly normal. Their watch would tick at its usual pace. Their thoughts would flow at their familiar speed. But to you, Watching from far away, they would seem frozen in time's gentle embrace. This stretching of time happens everywhere gravity exists. Even here on Earth, even in your quiet bedroom, gravity is gently bending time around you. The effect is strongest near Earth's surface and grows weaker as you climb higher. On the top floor of a tall building, time moves just a tiny bit faster than it does in the basement. The difference is measured in billionths of seconds per day, but it is real and measurable. Mountain climbers experience time slightly faster than people at sea level. Airplane passengers age just a little bit more quickly during their flights than people on the ground below. Astronauts on the International Space Station, orbiting high above Earth's surface, experience time flowing at a pace different from their friends and family below. These differences are so small that you would never notice them in daily life. But scientists can measure them with atomic clocks precise enough to detect changes smaller than the blink of an eye. GPS satellites orbiting Earth experience this gravitational time difference every day. They circle our planet at an altitude where Earth's gravity is slightly weaker than it is down here. This causes their atomic clocks to run faster than identical clocks on the ground. Engineers must constantly adjust for this time difference, or GPS systems would quickly become useless. Every time you use a map on your phone or navigate with a GPS device, you are depending on calculations that account for gravity's effect on time. The universe reveals its secrets through these precise measurements. Each satellite clock, each atomic timepiece, each carefully controlled experiment adds another piece to our understanding of how gravity and time dance together. As you rest in your bed, feel the gentle pressure of gravity holding you against the mattress. This same force that keeps your feet on the ground also slows time around you by the tiniest imaginable amount. Your heartbeat marks the seconds in your own reference frame, where time feels steady and familiar. But now you know that this familiar pace is shaped by Earth's gravitational embrace. You are living in a pocket of time that flows at the rate determined by your planet's mass and your distance from its center. If Earth were more massive, time would flow more slowly for you. If Earth were smaller, time would tick slightly faster. The planet beneath you acts like a cosmic conductor, setting the tempo for time's passage in your corner of the universe. Above you, astronauts experience time at a different pace. Below you, at Earth's center, time would flow more slowly still. The universe is filled with different streams of time, all flowing at rates determined by the gravitational environment around them. This connection between gravity and time shows us how deeply connected the fundamental forces of nature truly are. Space, time, matter, and energy are not separate things. They are different aspects of a single, unified reality that Einstein called spacetime. Gravity does not just pull on objects. It pulls on time itself, stretching it, bending it, shaping it according to the distribution of mass and energy throughout the cosmos. As your breathing deepens and your thoughts begin to drift, imagine the countless ways time flows throughout the universe. From the rapid ticking near black holes' edges to the leisurely pace in the vast emptiness between galaxies. You are part of this cosmic symphony of time, experiencing its flow at the rate set by your earthly home. 20,000 miles above your sleeping form, a constellation of silent guardians circles Earth in perfect harmony. 31 satellites drift through the darkness of space, their solar panels glinting like metallic wings in the sunlight. These are the GPS satellites. Mechanical angels that help you find your way home. Each satellite carries the most precise clocks ever built. Atomic clocks that measure time by counting the vibrations of cesium atoms. These timepieces are so accurate they would not gain or lose a single second in 300,000 years. But something beautiful and strange happens to these clocks as they orbit high above Earth's surface. They begin to tick faster than identical clocks on the ground below. This happens for two reasons, both discovered by Einstein over a century ago. First, the satellites move at tremendous speeds as they circle our planet. This motion should slow their clocks down through the time dilation we have already explored together. But they also orbit in a region where Earth's gravity is weaker than it is down here. Up there, in the thinner gravitational field, time flows more quickly than it does in your bedroom. These two effects work against each other like dancers moving in opposite directions. The satellite speed tries to slow their clocks down. Earth's weaker gravity tries to speed their clocks up. Gravity wins this gentle contest. The satellites orbit at just the right altitude where gravity's time-speeding effect overcomes motion's time-slowing effect. The result is that satellite clocks tick faster than Earth-bound clocks by about 38 millionths of a second each day. This might seem like an impossibly tiny difference. 38 millionths of a second scattered across 24 hours. But this small discrepancy would quickly destroy the GPS system's ability to help you navigate. GPS works through a miracle of precise timing. Each satellite continuously broadcasts the exact time according to its atomic clock. Your phone or GPS device receives these signals from multiple satellites and uses the tiny differences in arrival times to calculate exactly where you are on Earth's surface. If the satellite clocks ran even slightly fast or slow compared to Earth time, your GPS would become confused. It would place you in the wrong location. The error would grow by about 6 miles every single day. Within a week, GPS would be useless for navigation. Within a month, the errors would be measured in hundreds of miles. The system that guides airplanes, ships, and travelers around the world would collapse into chaos. But this never happens, because engineers perform a daily miracle that proves Einstein's theories correct. Every day, computers on Earth monitor the atomic clocks aboard each satellite. They measure precisely how fast these clocks are running compared to reference clocks on the ground. They calculate the exact correction needed to keep satellite time synchronized with Earth time. Then they send gentle commands up to space, instructing each satellite to slow its atomic clock by exactly the right amount. The satellites obey these commands with mechanical precision, adjusting their internal timekeeping to match the flow of time down here. This correction happens automatically, silently, while you sleep. Teams of engineers and computers work through the night to keep time flowing in perfect harmony between Earth and space. Without this daily correction, Einstein's predictions about time dilation would render GPS completely useless. The fact that GPS works so well that it can pinpoint your location to within a few feet anywhere on Earth proves that Einstein understood time's true nature. Every time you use GPS to find a restaurant, navigate to a friend's house, or explore a new city, you are depending on Einstein's insights about time and gravity. You are using a technology that could not exist without understanding how motion and gravity affect the flow of time. The GPS satellites carry more than atomic clocks. They carry proof that time is not the universal constant our ancestors believed it to be. They demonstrate every day that time can speed up and slow down depending on where you are and how fast you move. These mechanical angels orbit above you with a precision that would have seemed magical to previous generations. They know their positions in space to within a few feet. They know the time to within billionths of a second. They broadcast this information continuously, painting an invisible web of precise timing across the entire planet. Your smartphone connects to this web whenever you open a map application. In seconds, it determines your exact location by listening to the synchronized whispers of atomic clocks circling overhead. This everyday miracle happens because engineers understand Einstein's discoveries about time. They know that clocks run differently at different altitudes. They know that motion affects the passage of time. They use this knowledge to create technologies that seemed impossible just decades ago. The satellites themselves experience time at their own natural pace. To them, their atomic clocks tick normally and steadily. But from Earth's perspective, looking up at these orbiting timepieces, the clocks appear to race ahead of terrestrial time. This is the same relativity we explored with Elena and Maria, the traveling sisters. Different observers in different locations experience time at different rates. The satellites live in their own temporal reference frame while we live in ours. The daily corrections create a bridge between these different experiences of time. They allow the satellites' faster ticking clocks to stay synchronized with Earth's slower ticking clocks. Technology becomes the translator between different flows of time. As you rest in your bed tonight, those 31 satellites continue their silent dance overhead. Their atomic hearts beat with mechanical precision. Their radio voices whisper timing signals across the darkness. Their existence proves that Einstein's strange predictions about time are not just theoretical curiosities but practical realities that touch your daily life. Tomorrow, when you wake and check your phone for the weather or directions, you will be receiving information made possible by our understanding of time dilation. You will be benefiting from humanity's hard-won knowledge about time's flexible nature. The GPS constellation above you represents one of the most beautiful collaborations between pure science and practical technology ever achieved. Einstein's thought experiments about racing alongside light beams have become the foundation for a navigation system that guides millions of people safely home each day. High above your sleeping form, invisible messengers rain down from the cosmos like gentle snow. These travelers have journeyed across vast distances of space, born in the violent collision between cosmic rays and Earth's upper atmosphere. They are called muons. Particles so small that billions could dance on the head of a pin. Yet these tiny wanderers carry within their brief existence one of the most beautiful proofs of Einstein's insights about time. A muon lives for only 2/millionths of a second before it transforms into other particles and disappears forever. This lifetime is fixed by the laws of nature. It cannot be changed or extended by any force known to science. Or so it seemed until scientists began to study these cosmic visitors more carefully. When muons are created 20 miles above your head, they should decay long before reaching Earth's surface. Even traveling at nearly the speed of light, they simply do not have enough time to complete their journey downward through our thick atmosphere. By the mathematics of their brief lifespan, these particles should vanish high in the sky, leaving no trace of their existence by the time you might hope to detect them down here. But something magical happens instead. Muons reach Earth's surface in great numbers. They pass through the roof of your house. They drift through your bedroom walls. Some even travel through your sleeping body as you rest peacefully in your bed. Scientists can detect thousands of these cosmic travelers every hour, proving that far more muons survive their atmospheric journey than should be possible according to classical physics. The answer to this puzzle lies in time's flexibility. The muons race through our atmosphere at tremendous speeds. At these velocities, time dilation stretches their brief lives like warm honey pulled between gentle fingers. From Earth's perspective, the muons appear to live longer than they should. Their internal clocks run more slowly, giving them the extra time needed to complete their journey to the surface. To the muons themselves, racing through the atmosphere, their lifespans feel perfectly normal. They experience their standard 2/millionths of a second before decay. But this time passes more slowly relative to Earth's reference frame. It is as if the muons slip between the raindrops of time, finding spaces that allow them to exist longer than the universe's rules would normally permit. This same principle works in the laboratories where scientists study the smallest building blocks of matter. In particle accelerators around the world, researchers speed tiny particles to incredible velocities and watch time dilation bloom like flowers in a cosmic garden. Picture a vast underground ring where particles race in circles at nearly the speed of light. The ring stretches for miles beneath the countryside, its tunnel lined with powerful magnets that guide the particles along their endless track. Inside this ring, protons circle thousands of times each second. At these tremendous speeds, time moves more slowly for the racing particles than it does for the scientists who study them. Unstable particles that would normally decay in microseconds live much longer when accelerated to these incredible velocities. Their extended lifespans allow scientists to study their properties in detail, revealing secrets about the fundamental nature of matter and energy. These experiments provide some of the most precise measurements of time dilation ever achieved. Scientists can predict exactly how much longer particles should live at different speeds, and their measurements match Einstein's equations with extraordinary accuracy. The dance of particles through time happens at velocities that dwarf anything we experience in our daily lives. While a fast car might reach 100 miles per hour, these particles move at speeds measured in significant fractions of light's ultimate velocity. At such speeds, time dilation becomes dramatic and unmistakable. A particle that would normally live for 1 microsecond might survive for 10 microseconds when accelerated to 90% of light speed. Time stretches around these tiny travelers like a protective blanket. In the most powerful accelerators, particles reach velocities so close to light speed that time dilation becomes extreme. These particles experience time flowing hundreds or even thousands of times more slowly than we do. From their perspective, racing around the accelerator ring, they complete their brief lives in what feels like normal time. But from our perspective, watching from the laboratory, they seem to live in slow motion, their decay processes stretched across impossibly long intervals. This stretching of time allows scientists to study processes that would otherwise happen too quickly to observe. It opens windows into the quantum world that would remain forever closed without Einstein's insights about time's flexibility. The muons raining down from space and the particles racing through accelerators tell the same story. They show us that time is not the rigid framework our ancestors imagined. Instead, time bends and stretches according to the speed at which objects move through space. Every cosmic ray that strikes Earth's atmosphere creates a shower of these time-dilated particles. Every particle accelerator becomes a laboratory for studying time's elastic nature. The universe provides countless examples of Einstein's predictions playing out on scales both cosmic and microscopic. As you rest in your bed, these invisible demonstrations of time dilation surround you. Muons drift through your room, their extended lives made possible by their tremendous speeds. In laboratories around the world, particles race through rings and tunnels, stretching time with their velocity. These phenomena happen beyond the reach of your senses, yet they confirm truths about reality that touch every aspect of existence. They show that the universe operates according to principles far stranger and more beautiful than everyday experience might suggest. The particles dancing through time around you carry messages from the deepest levels of physics. They whisper that space and time are woven together in ways that allow for flexibility, for stretching, for the bending of duration itself. Scientists study these tiny messengers with instruments of incredible precision. They measure lifetimes down to billionths of seconds. They track particles through detectors that can sense the passage of a single subatomic wanderer. Through these careful observations, humanity has built an understanding of time that encompasses everything from the smallest particles to the largest structures in the cosmos. We have learned that time is not separate from space, not independent of motion, not immune to the influence of matter and energy. The muons passing through your sleeping form tonight are living proof of these insights. They exist in a state of extended time, their brief lives stretched by velocity into something longer and more graceful than the laws of static physics would permit. In their dance through time, these particles become teachers. They show us that the universe is more flexible, more generous, and more mysterious than we ever dared to imagine. Close your eyes and let your imagination carry you to a place where dreams and physics dance together. Picture yourself standing at the edge of possibility, where the future whispers your name with a voice both strange and familiar. Time travel has lived in human dreams for generations. Stories of magical machines that can carry us backward to witness history or forward to glimpse tomorrow. Tales of spinning wheels and crackling electricity, of complex devices that bend time to human will. But the universe holds a more elegant secret. You are already a time traveler. You have been one your entire life, moving forward through time at the steady pace of 1 second per second. But Einstein's discoveries reveal that this pace is not fixed. Not unchangeable. Not the same for everyone. The future is not a distant shore that you can only reach by waiting patiently for time to carry you there. The future is a destination you can approach more quickly by understanding time's flexible nature. Every step you take moves you through space. And every movement through space affects your journey through time. The faster you move, the more slowly time passes around you. The more slowly time passes, the more quickly you slip into tomorrow. This is not science fiction. This is the gentle mathematics of relativity, proven by every atomic clock, confirmed by every particle accelerator, demonstrated by every GPS satellite circling overhead. If you could somehow travel at 90% of light speed for what feels like 1 year to you, you would return to find that more than 2 years had passed on Earth. You would have journeyed into the future by skipping gently over the intervening time. The faster you travel, the more dramatic this effect becomes. At 99% of light speed, your 1-year journey would carry you 7 years into Earth's future. Time dilation becomes your vessel for sailing forward through the years. This form of time travel has limits. You can move forward through time more quickly than normal, but you cannot return to the past. Time's river flows in only one direction, carrying you always toward tomorrow, never back to yesterday. But within this constraint lies breathtaking possibility. Imagine an astronaut volunteering for humanity's first journey to a distant star. She climbs aboard a spacecraft capable of tremendous speeds and begins her voyage into the cosmos. To her, the journey unfolds at a normal pace. She experiences each day, each meal, each moment of wonder as she travels between the stars. But when she returns to Earth, she discovers that decades have passed while she experienced only years. Her friends have grown old and grey. Children she knew have become adults with children of their own. She has traveled into the future through the simple act of moving very fast through space. This astronaut becomes a bridge between two different times. She carries memories from an earlier era into a later one. She becomes a living connection between the world that was and the world that is. Scientists have calculated the exact specifications for such journeys. They know how fast a spacecraft would need to travel to achieve different amounts of time dilation. They understand the energy requirements, the engineering challenges, the physics that would make such voyages possible. Today's technology cannot build the engines needed for such speeds. But the laws of physics do not forbid them. The universe places no absolute barrier between us and these temporal journeys. Only the practical challenges of engineering and energy stand in our way. Even at more modest speeds, time dilation creates opportunities for adventure. A spacecraft traveling at half the speed of light would experience time dilation effects that accumulate over long journeys. Passengers might age months while Earth ages years. These travelers would return to find their home planet subtly changed. New technologies. New discoveries. New generations of human beings carrying forward the great project of understanding our universe. But time travel into the future does not require fantastic speeds or impossible technologies. It happens around you every day in small, gentle ways. When you climb to the top of a tall mountain, you move slightly into the future relative to people at sea level. When you fly in an airplane, you experience time at a pace fractionally different from people on the ground. When you simply walk across your room, you participate in time dilation effects too small to measure but absolutely real. Every choice you make about how to move through space becomes a choice about how to move through time. Physics does not distinguish between these two aspects of reality. Space and time are woven together into a single fabric that responds to your presence and your motion. The future calls to you through these subtle invitations. Not with the harsh voice of science fiction, demanding impossible sacrifices and dangerous gambles. But with the gentle whisper of actual physics, offering real pathways toward tomorrow. Perhaps future generations will build spacecraft capable of the tremendous speeds needed for dramatic time dilation. Perhaps they will develop new forms of energy that make such journeys practical and safe. Or perhaps they will discover that the greatest time travel adventures happen not through extreme speeds but through patient observation of time's dance around us. Perhaps they will find wonder in the small dilations that surround us constantly. The muons raining down through your bedroom tonight have traveled from the past into the present through time dilation. The GPS satellites overhead slip moment by moment into the future relative to earthbound clocks. The universe demonstrates time travel principles continuously, on scales both cosmic and intimate. You participate in this cosmic dance with every breath, every heartbeat, every gentle movement through your daily life. You are already aboard a time machine called Earth, spinning through space at thousands of miles per hour, carrying you constantly forward through the flowing river of time. As your thoughts begin to drift toward sleep, imagine the possibilities that Einstein's insights have opened for humanity. Picture the gentle astronauts of tomorrow, voyaging between stars while time stretches around them like silk in a summer breeze. These voyagers will carry with them the accumulated wisdom of our species. They will be ambassadors from our time to future times, living bridges across the years. Their journeys will prove that time travel is not the exclusive domain of fantasy but the natural birthright of any civilization that understands the flexible nature of time. The future waits patiently for us to develop the courage and the technology to visit it more quickly. But it does not wait passively. It calls to us through the mathematics of relativity, through the whispered promises of physics, through the demonstrated reality of time dilation effects that surround us always. Take a deep breath and feel yourself returning to this quiet moment. Your journey through time's mysteries has carried you across vast distances of understanding. You have traveled alongside light beams with young Einstein. You have watched clocks slow down in racing spaceships. You have witnessed sisters age at different rates and particles dance through stretched seconds. Now you come home to the gentle rhythm of your own heartbeat, to the familiar tick of time in your peaceful bedroom. But something profound has changed during your journey. The moment you inhabit now feels different than it did when we began together. Time itself seems richer, deeper, more alive with possibility than you ever knew before. The clock on your nightstand continues its steady march through the seconds. But now you understand that this steady pace is not universal. It is not the same everywhere in the cosmos. It is simply the particular tempo of time as it flows around you here, in Earth's gentle gravitational embrace, moving at your quiet earthbound speed. Your breathing creates its own rhythm within time's larger flow. Each inhale brings oxygen to your cells. Each exhale releases the waste of cellular life. This biological dance has been synchronized with time's passage for every moment of your existence. But now you know that this synchronization could change. If you were to travel very fast, your breathing would feel the same to you, but it would appear slower to observers watching from a different reference frame. Time would stretch around your biological processes, keeping your internal rhythms consistent while changing your relationship to the outside world. The light from your bedside lamp reaches your eyes at precisely 186,282 miles per second. This speed has never changed throughout the history of the universe. It will never change in all the billions of years to come. Light's constancy creates the cosmic heartbeat around which all other rhythms of time must dance. This same light that illuminates your room has traveled similar journeys throughout the cosmos. Light from distant stars has crossed millions of years to reach Earth tonight. Some of the photons entering your eyes began their journeys before human civilization existed. They carry messages from the deep past, delivered at time's most sacred speed. The molecules in your body move constantly, vibrating with thermal energy, flowing through chemical reactions that sustain your life. These molecular dances happen at their own natural rates, but even these microscopic rhythms would change if you were to approach light's ultimate speed. Everything in your physical existence is woven into time's fabric. Your thoughts emerge from electrical patterns in your brain. Your heartbeat results from coordinated contractions of cardiac muscle. Your dreams unfold as networks of neurons create experiences that feel as real as waking life. All of these processes happen within time, shaped by time, inseparable from time's flow. Yet now you understand that time itself can bend and stretch according to the fundamental laws Einstein discovered. As you rest in your bed, you are moving through space at tremendous speeds without feeling any motion at all. Earth spins on its axis, carrying you in a circle at about 1,000 miles per hour. Earth orbits the Sun at roughly 67,000 miles per hour. The Sun moves through our galaxy at hundreds of thousands of miles per hour. Yet you feel perfectly still because you share these motions with everything around you. Your bedroom, your house, your entire world participates in these cosmic dances. From your perspective, you rest peacefully while the universe moves around you. But if you could somehow step outside these shared motions, you would see yourself racing through space at incredible velocities. You would witness the time dilation effects that your movement creates, effects normally too small to notice but absolutely real. The GPS satellites overhead experience these effects directly. Their clocks tick faster than yours because they orbit in a region where Earth's gravity is weaker. Engineers correct for this difference every day, proving that Einstein's insights about time are not just theoretical curiosities but practical realities that touch your daily life. High above, muons created by cosmic ray collisions continue their gentle reign through your bedroom. These particles experience time dilation that allows them to reach Earth's surface despite their brief natural lifespans. They pass through your body as you sleep, invisible messengers carrying proof of time's flexibility. In laboratories around the world, scientists continue to study time's mysteries. They accelerate particles to tremendous speeds and watch their lifetimes stretch. They fly atomic clocks on airplanes and measure the tiny differences that motion creates. They search for new ways to test Einstein's predictions about time and space. Each experiment confirms what your journey tonight has revealed. Time is not the rigid framework our ancestors imagined. Time is alive, flexible, responsive to motion and gravity in ways that create opportunities for wonder and discovery. The universe you inhabit is far stranger and more beautiful than everyday experience might suggest. Space and time are woven together into a single fabric that can bend, stretch, and curve. Matter and energy dance through this fabric, creating the complex symphony of existence that includes your own consciousness. You are part of this cosmic composition. Your thoughts participate in the universe's attempt to understand itself. Your wonder about time's mysteries connects you to the deepest questions about reality's nature. As your eyes grow heavy and your breathing deepens, let this understanding settle gently into your awareness. You live within Einstein's universe, where time flows like honey around massive objects and stretches like silk around objects moving at great speeds. The seconds that carry you toward sleep tonight are not just empty containers for experience. They are dynamic, living aspects of space-time itself. They respond to your presence, to your motion, to the gravitational field that holds you against Earth's surface. Tomorrow morning, when you wake, you will have traveled through time while you slept. Not just forward at the usual rate of 1 second per second, but forward through a night shaped by subtle time dilation effects too small to feel but absolutely real. The sunrise will bring photons that have journeyed from the sun in just over 8 minutes, traveling at their eternal, unchanging speed. These photons will touch your face and remind you of light's role in revealing time's secrets. Your day will unfold within time's flexible embrace. Every step you take will create tiny time dilation effects. Every breath will participate in the biological rhythms that synchronize your life with time's flow. And throughout it all, you will carry with you the knowledge that time is not separate from you. Time is not external to your existence. You live within time, and time responds to your presence in ways both subtle and profound. The universe has shared its secrets with you tonight. It has revealed that time travel is not fantasy but physics. That clocks can run at different rates. That the future calls softly to those who understand motion's relationship to time.